the train's here right on time. Looks like we're live on YouTube and Twitch. Welcome back to the stream, everyone. Anyone? So this is kind of a regular work-in-progress stream. In case you haven't been here before, I make videos that show up on my main channel, Scanlime. Sort of an eclectic mix of forward and reverse engineering these days. But I try to make a habit of taking things apart and investigating how they work. So today's stream is kind of in that vein. I've got a bit of hardware that I had some curiosity about, and I thought I would dig into it on video. So, hello. I think we've got Tuco the cat here too. Let's get a little closer. How's that? He seems fine with this. Oh, were you leaving already? Yeah, he's down here by my feet now. Hey, boy. Are you gonna chew on USB cables? I'd rather you don't. I might have to start protecting my USB 3 and HDMI cables the same way I do with power cables. Anyway, man, it's just so hard to get away from the cat camera these days. I mean, he's worth spending plenty of time with on video, in my opinion. This is, after all, the Electronics and Cat channel, apparently. The Yeti says hi on YouTube chat. Hello. Are you the same Yeti who makes all those t-shirts for GDQ? Oh, we lost him under the table, I guess. Every time I stream, the mess is in a slightly different shape, at least. This time it's sort of in an L shape. With this clear area in the middle and some stuff I was sorting. And oh, you can barely see the IR coming out of that. That's one of those lighthouse base stations. Anyway, Tuco's on the desk now. He seems to eventually end up here when I'm streaming, usually. There's still a bug I've been dragging my feet on fixing that makes it kind of hard to move the winch smoothly at low speeds. There we go. It was taking a while for the forces to converge. There we go. Well, Tuco has finally led us to the subject of today's stream. So this might not be a really long stream, but I wanted to at least dig a little bit into this device here. Is it a mouse? Is it a camera? I think it's both. It's a camera, but it's called a mouse. So Hey Tuco, where do you want to be? I want to make room for Tuco and the camera here. You're just gonna sit right there. That's cool. Let's make sure that's clean. Okay, cool. Can we do this? Are you investigating my Raspberry, Tuco? That is an original Raspberry Pi. I imagine that's kind of a sharp place to lay, though. There's some pins there. Is that better? That seems better. He's purring now. All right, so I got this kind of recently, actually, just because in some situations I actually find like just biometric login for local user accounts pretty handy, because it's, I think, harder to, it's harder to like steal and repurpose the biometric data in most cases than I think like shoulder surfing a password, which is something that I worry about a lot given how much video I record here. It's like nice to have local credentials at least that are harder to just surf accidentally via video. So, like that's one of the reasons that like when I'm just like here, it's nice to be able to use fingerprint login on my phone. If I was traveling, I might not do that, but like the threat model here is such that I'm more worried about accidentally broadcasting credentials to people than I am about like a targeted attack or whatever. So anyway, that led me to research just like, well, what would it take to get the Windows Hello login working, at least on my main workstation down here? And there are these kind of inexpensive, basically webcams that include some additional hardware features. It looks like this might be an IR camera, possibly something that includes RGB and IR channels for each pixel. It might also include IR illumination. It might also include some kind of encrypted protocol. So I thought it'd be really interesting to dig into this a little bit. So this is a mouse facial recognition camera for Windows Hello, I guess is the title here. So yeah, I'm kind of curious how different this is from a regular webcam, both at the hardware and the software layer, and what the traffic over the USB wire might actually look like. And I thought it might be a good opportunity to investigate that using a tool that I find pretty useful. It's certainly not the only way you can capture USB, but one way to do it, one way to do a USB log where you run some driver or application that's talking to some hardware and you want to know what the communication is between those two things, like what's actually going across the wire. You can do that in a number of ways. My favorite, really, if you have the cache to get one of these hardware analyzers, like the Beagle 480, or there are a handful of other options at this point, but this was a pretty good price-performance trade-off when I got it. This gives you like USB pass-through, where you can connect one of these ports to a PC, one port to the device. The USB just goes straight through this box, but it logs all of the data. And then you can stream those logs back to a different PC or the same PC for analysis purposes. So with those, you can log anything that goes over a USB wire pretty much. You can get very accurate timestamps. You can do it without affecting the traffic that you're trying to log at all. It's very powerful, but those devices aren't cheap. Even a really basic one will set you back a couple $100, and one that handles high-speed USB will generally be like several $100s at least. So if you want a way to log data without having to shell out for expensive hardware, then it could be compelling to look for a way to do this in software. And so then that starts to depend on what operating system and what environment you're dealing with. So if you're running everything on Linux these days has some USB logging support built in that you can even use with Wireshark, so that's pretty convenient. If you're running on Windows, there are some USB logging tools for Windows. There's actually a bunch of them. There was a pretty old one called USB Snoopy for a while that I think at this point is pretty obsolete. I don't know that you could run it on modern versions of Windows. There have been some commercial ones. They generally work by loading a driver into the USB driver stack that kind of sits like think typically between the hub driver and the host controller driver, and then logs all the IRPs, the I/O packets that go between those layers. So there are various implementations of that. I haven't really dug into like what people use on Windows 10 as far as software analyzers. And then there's that's hardware boxes, which are expensive but very reliable. That's Windows and Linux. There used to be a built-in USB logger for Mac OS, but they haven't released a new version of it in many major versions at this point, like many years. So it's been a long time since Mac OS had a working software USB logger, and I've never known of any third-party USB loggers for Mac OS. It would be possible, but a lot of work, and I think the people who are interested in that just end up buying hardware analyzers for the most part. So then there's virtual machines. Anything you can run in a virtual machine on a Linux host, you could use the Linux USB monitor and then just record those traces and use Wireshark. So that's a technique a lot of people are into. I'm going to be doing something similar here, but with a macOS host, and I'm going to just be demonstrating how to do the logs using VMware Fusion, but the same process works with any of the VMware products. There's just some config file options you can set that have it log all the USB data to the main VM log file. And with some additional options, you can kind of turn off some of the built-in devices to make it less noisy, and you can remove some of the log throttling that's built in so that you can actually get a full data report instead of just summaries. So, yeah. I guess that's pretty much where we're at. I guess my thought was we could do a basic unboxing to get that footage. Then if it looks easy to take apart, then let's just go ahead and break into it and look at the chips on the board and get some microscope footage. If it looks like it might be hard to take apart without destroying it, then we might put that off and or not do that part, but because I would like to use this device, but yeah, I think depending on how hard it is to break into, we'll do some combination of opening it up and photographing it and actually looking at the USB protocol today. Alright, well, I guess as compelling as Tuco is, maybe I should try to find a camera angle that lets me look at this box. Yeah, so what do they mean by this? It says it has a depth sensor, which could be interesting. I did a brief search just to see if if there was any published information about what requirements Microsoft has for vendors that are implementing facial recognition cameras for them, but I didn't really see anything public. I don't have like an MSDN subscription in case it's on there. Just want to make sure I get enough footage to edit together interestingly. Yeah, I don't totally know how long I can stream today. I might have to coordinate stuff with friends at some point, but I'm gonna do what I can. So yeah, the point of this camera is that it's for login use. It's a face recognition camera that's designed for biometric login. And so I'm curious what makes it different from a regular webcam in terms of hardware and protocol. That's interesting. So there's like a ribbony thing, which just seems to be glued to some foam in there. And this is all just foam. It's really thin. Wow. I did not expect it to be this thin. So we've got the layer of foam. This is thick foam too. Thin cardboard. Too good, you like foam. There's the actual camera. It's got a little protective film over the front. What else is in here? Just some paper, specifications, FCC stuff, remove protective film before use. You can either stick it on a desk or on the top of a monitor. It's got a captive USB cable, it looks like. Comes with a driver. Oh no, it says there's a built-in driver on Windows 10, but it comes with a driver for Windows 7 and 8.1. That's interesting. I wonder, I mean, I assume that's not for login though, it's only for use as a camera. It's interesting. So you think these wide ones are illuminators? I'm guessing it's got an RGB camera and a time of flight infrared camera. And then maybe these are both IR illuminators? If that's the case, then this is going to be the IR camera, and then this one over here on the side is probably the RGB camera. And then is that a little... that just might be a bubble right there. Oh yeah, Dean's betting it's a projector. Yeah, I don't know whether this would be a projector style or a time of flight style. I was kind of guessing time of flight since they're usually smaller these days, but I don't know. All right. So we've got regular Phillips screws for the Hinge base thing, which we probably don't need to get into. This is probably just hinges and a little bit of weight. Captive USB 2 cord. It claimed to be USB 2.0, which probably means high speed to them. There's a parting line right down there. So the way this hinge is built, this middle section seems to be the same piece of plastic as this back, but maybe the pin on the hinge is removable? Is that a cap? I need to get more light over here. Oh, that is very much a cap. a sticker. My hand and the light are fighting over angles here. There we go. That seems to be just a pin end. It's not actually clear to me that we... Oh, I could have not dropped that. It's not really clear to me that I need to take the pin out, but I'm curious. Yeah, so that doesn't seem necessary. It's probably just to keep the dust out of the hinge. So I could try to push that out, which might be useful, but it might not be. Could also just try prying open the two halves here. See where they're attached. Oh, did you find API documentation? That's cool. Oh yeah, and Josiah points out that they'd be curious to see what the FCC page says about the internals. Yeah, for sure. That would definitely be a thing you could do instead of or in addition to taking it apart. Snaps. Marring the surface a little bit, but it's not too bad. It's definitely just snaps. This would be easier if I wasn't trying to get it on camera. This is usually how it goes. Trying to get it on camera and trying not to hurt Tuco. Wow, that's cool. It's a compact little module. This has got to just be an OEM depth camera module. That's interesting too. There's a little controller board over here, which might just be power regulation. A lot of wires. We'll definitely take a closer look at all this. Let's just temporarily unplug the captive cord. This is shielded, and then it's just got the regular 4 USB 2.0 contacts there. It's using the standard color codes even. So black there is ground and shield, red is 5 volts, then white and green are, I think that's D- and D+. But I always have to look it up if I really need to keep the order of those two straight. And then this is on a peg. I'm guessing this is also glued. Both of these look glued. There's also an interesting footprint over here. I'm wondering, like, that at first glance seems like, oh, that's a test point or something, but actually that looks like a spot for RGB LEDs, maybe. These are big infrared blasters, these two. So then that's definitely going to be the IR camera and the RGB camera. It looks like this metal can is all soldered down, which is unfortunate. That is a bit flexy. Yeah, that is... So this whole assembly is glued down. I'm a little worried about flexing it if I just try to pry it off, which could damage the circuit board or just cause the optical alignment to completely change. So it's tempting to maybe leave this board attached just for the moment, but I do want to at least look at both sides of this little board. No, that one should be easy to get off. Alright, tiny connector. Oh, under that there's some test points. Covered with Kapton. That could definitely be some kind of programming interface. It seems like the bottom side of the board is flat, and this is just an adhesive strip. That works. Yeah, I would worry about damaging the board if I hadn't softened the adhesive a bit. So flat area on the back. Then just some markings. Let's take this under the microscope. Oh, hey, Took. lot of space to grab this by. Might switch to the stick vise. Alright, so there's the USB entry. That's some EMI filtering. So that's probably a common mode choke or a couple of filter beads. Some capacitors. I don't know about that C5 device right below the smaller capacitor. I'm guessing that might be a transient suppression diode. Capped on. That's probably a voltage regulator. Yeah, gross. Oh, this would be easier if I had this monitor on also. Wake up monitor. Ooh. Is that a capacitor or an inductor? Looks like a capacitor. Oh no, that's an inductor. I think that's the ferrite bobbin that you're seeing on the top, and then that kind of cement looking stuff is covering the windings. At least I think that's what I'm looking at. Might be some kind of really weird capacitor, but I'm guessing that's power filtering. This might be a switch mode controller, or that might just be an LC filter. I'm not actually sure at this point. But yeah, this could be a little switch mode controller. So we definitely can see the USB pairs just going straight to, what is pin 1? I assume that's pin 1 on the right. So we'd have ground, we have ground, then I don't know what the next one is. It's going to some vias, might be a power fill. Then we have USB, and then 4 more pins, which could be, like, that one on the left seems to be going to that polygon, which might indicate it's a different voltage. So I'm guessing we're going to have 5 volts, 3.3 volts, and maybe a couple of no connects. But I don't know why they would have fully populated the wiring harness here if it was no connects. There could also be some other stuff like an enable, or I doubt you'd see a second voltage, because a second voltage you'd probably, I mean, if this is a switching converter, then you'd see a second inductor. Anyway, so yeah, I don't know why they designed it with this little power supply shim board, but my best guess would be that this is some kind of OEM module that they're adapting for use externally, but it's commonly inserted like internal to a laptop or tablet. So yeah, there's the test point area that was covered up, one of the IR emitters, big piece of silicon. That's either a different type of IR emitter footprint, or it's some kind of visible LED. I don't know which. That's a visible LED, but not like a multicolor LED probably. That's the visible camera. Sticker, another unpopulated spot. And then it looked like that was soldered. Oh, is that not soldered? No, I don't know. It's hard to tell with the glare, but I think that's soldered on. I'll try poking at it with a knife, though. That is definitely solder. That is firmly attached. So I would have to do some extensive either cutting or heating to get this shield off. So I think right now I'd rather plug this thing in and see what it's like from a protocol perspective than risk destroying the one board that I have here. And it's disappointing we can't really see any of the important circuitry since it's all under the shield. However, if they're trying to make this device hard to tamper with without detection, this kind of construction helps a little bit. And obviously, like if I had a motivated kind of hardware modification I was trying to do, I could probably make it arbitrarily complex if I could prepare a device and like swap it out ahead of time, that kind of thing. But like I don't know, that's probably like direct attacks against this hardware are probably not the kind of thing that are really that important to protect against for the Windows Hello threat model, whatever that actually is. I mean, I suspect what they're worried about for most users' security is some method of capturing a password which can then be used on like web-based accounts by a remote malicious party. So like a keylogger or a malware of some sort or malicious hardware. This infrared emitter is pretty, at least. Anyway, let's put this other board back on. I might just basically put this back together. I don't know if there's much we can do with the internals at the moment. I mean, we could probe the voltages on this connector, maybe. Alright, just sticking that board back on. Remembering how all this stuff goes back together. Alright. That's right, there was a little piece of cap on there to keep that from shorting out, which it would otherwise. That needs to be smaller though. Alright, little capped on. I might as well put this cover back on because it has some filters which might be useful, and it will keep cat hair from getting on the emitters. that is reassembled. Let's see what this looks like in a VM. Good kitty. Alright, I'm going to point this in the desk orientation somewhere at least. Alright, so I've just plugged it in over USB. It's not doing anything yet. Alright, let's just see what this looks like in USB Prober from macOS's point of view. RGB IR camera, high-speed device. That's cool. This seems to be a USB video class device. Wow, I wonder if macOS knows how to read from it. That would be a big yes. There's a blue light. So you can use it as a basic video conferencing device, I guess, in any operating system. Yeah, let's see if we can find the IR interface in UVC here. Like, I wonder if any open source UVC clients know how to like choose different streams or whatever it is that we would need to do to actually use the IR camera. Okay, so this is all based on a node graph, kind of like USB audio devices are. So the USB descriptors include information about like cameras and endpoints and what processing the device can do. So this seems like it might be the main color camera. It's got MJPEG formats, which I wouldn't expect for the IR camera, maybe. Are these just all different isochronous bandwidths for the different frame formats? Yeah, I don't think this level of visibility into the USB descriptors is going to help that much. Anyway, that's cool. Let's see what Windows 10 ends up doing with this. So here's the setup. I've got one of these Windows 10 evaluation VMs that you can download from Microsoft for free. I've got a Linux VM. The Linux VM I am using to run VUSB Analyzer. There's actually a version of VUSB Analyzer in Ubuntu, but it doesn't work on modern versions of VMware. So this is the program I'm talking about. You can find some old instructions for it if you go to vusbanalyzer.sourceforge.net. This is a web page I wrote like a lifetime ago back when I worked at VMware, but I don't currently have any access to it, so it's out of date. but it has some basic info about this tool in this tutorial. So this is kind of useful if you're interested in this tool. There's also a little bit more modern info in my GitHub. I've got this VUSB analyzer repository, which was updated 4 years ago, so it's still not that new. And this program has some pretty severe bit rot, such that it basically needs an old Ubuntu VM to run it. It depends on this library called GNOME Canvas that's been deprecated for a really long time now. So yeah, it might not be the best option, but I still kind of like it, and I thought it would be worth trying to demo with it here. I think the other option that I'd recommend if you are less interested in like ancient tools like this is to just use Wireshark on a Linux host. But this method is kind of cross-platform. Like, this analyzer tool is kind of annoying to run anywhere that isn't Linux, but you can capture the logs anywhere, so you can use any host operating system that the VMware programs will support. So this is mentioning a few things to add to the log, or to the config file. So some of this you can actually add from the GUI. So if you go to the VM settings, under advanced, so you might have to scroll down to get to this, but there's enable verbose USB debugging. So this is necessary, but not the only thing I would recommend. So start with turning this on. Start with that, but then close this, because you don't want to edit the VM config files while the VM is open, because the UI might clobber your edits. And then you want to go to the command line and find the actual VM file. So this would be in documents, virtual machines by default, and then it's that .vmware directory was actually the thing that you downloaded from Microsoft, and the .vmware VM is VMware Fusion's VM package format. But it's really just a directory that includes a bunch of other stuff. If you're using VMware Workstation or Player, you might just see the contents of this directory just like hanging out somewhere without the .vmware VM bundle. The bundle thing is just a Mac OSism, really. The important parts are the VMX file, which is the configuration file for the whole VM, and the log file, which is the output. You'll also notice that obviously there's a virtual disk and a memory file here. The memory file only exists when the VM is powered on, but it's actually mapped memory. The snapshot is like hardware state. Or no, actually the vmem file still exists when the VM is suspended also, if I remember right. But then vmss, I thought that actually got a serialized copy of main memory. But that's way too small. Yeah, maybe main memory stays in vmem, and vmss is just the serialized virtual hardware state. So then that's the disk and a header. There's a bunch of other stuff here that's used for snapshots, but the most important part is this VMX file. So sometimes I'll just use star.vmx to select it, because there's always only one VMX file in the directory. So yeah, these files are actually, like, people who work at VMware edit these by hand all the time, and if you search for like hints for solving particular problems in the knowledge base or on the forums, they'll tell you to edit these files all the time, but they're not really documented. And even like internally at VMware, we never had documentation for this. It was basically just like you write code that accesses the config file and gets values from it, and you can just kind of do that anywhere. So people just developed kind of ad hoc strategies for how to arrange these values. So yeah, some of it doesn't make that much sense. The naming conventions are a little bit inconsistent and whatever, but you can usually, if you need a hint for what values are supported, you can just run strings on the VMX. So the VMX is the big user space binary that does pretty much everything in VMware. You can find its path pretty easily just by running ps, but on macOS it's going to be in this, this library directory here. Oops. So yeah, it is also owned by root and set UID root. It is very privilegey. Let's just run strings on it. So here you can see mouse.vusb.enable, all these things. One place where this came into play just recently is I was trying to disable the virtual USB mouse using this command line option, or this config option. I think at some point the way this worked changed, and it's no longer just like a hard enable disable, but it's like kind of a stateful device that's persisted with the rest of the USB device connection state. And because of that, the way that you configure it is more like, should this start connected? But after that point, it's actually part of the VM's snapshot. And then separately, should the state be visible in the UI so that you can actually adjust it? So there's a couple of options I'd recommend for that, actually. You can turn off the mouse by default. The USB mouse is actually kind of this handy feature that lets the VM provide an absolute positioned mouse to guests that don't have any specific driver support for this. So it's really useful. You can also live without it if you have VMware tools installed, because there's a couple of other different mouse mechanisms that it will switch to. Yeah, turning this off is usually not recommended, but if you're taking VMware or if you're taking USB logs of a VMware VM, then you can actually use that just to make the logs less noisy. And so I do that sometimes. These two settings are both about making devices visible to the UI. So normally HID devices are just hidden entirely from the UI, just to keep you from accidentally attaching HID devices to the VM and locking yourself in. So this relaxes that check and allows all HID devices to be visible, not just HID devices that we think are safe. And then this makes the virtual mouse devices also visible. So those are also kind of handy. Then I also add some stuff from here. So this max line, normally the length of USB log entries in the log are limited to just a few lines long, and that lets you see the beginning of the transfer. But if you want like actually all the data, then that truncates the data that you're interested in. So when I'm doing debugging, I'll often just turn that to something that's really large. 8192 is just an arbitrary large round number that's bigger than you would ever find in a real packet. And then this is another feature related to log, just like getting all the data in the log. There's like a lower level log throttling mechanism where just if anything in the VMX is writing to the log too fast, it'll throttle the whole thing just to keep it from bottlenecking on that. So we want to disable that. And this is allowing, what is this, 100 megabytes a second of log writes, which I think is probably fine. So yeah, you can customize this. Definitely do the customizations with the VM closed and powered off, or suspended. You could do it with VM suspended also, but that will make some of the options a little weird because some things end up getting loaded from the snapshot state, but yeah. So then after you've done the edits, you can open the VM again. On macOS, you can just like open dot as a shortcut. So here it should be resuming. As soon as it starts resuming, there's going to be a VMX process. So you can see I've got one for the Ubuntu VM now and one for the Windows VM. And if I start tailing this log file, it'll actually be doing stuff. So you can see everything resuming. Haha. David says VMware has quite a few large set UID root binaries. I mean, that's basically their whole strategy, is large set UID root binaries. Yeah, they're not really big on privilege isolation in depth. That was something that I was always frustrated about when I worked there. It was really hard to get anyone to think about defense in depth, and like there was this one particular project I wanted to do for a long time where, for multiple reasons, but security was one of them. Security, as well as other reasons, I wanted to move like the graphics processing into a lower privileged process, and I just like gave up after trying to argue for that. It was just hopeless. It was like there were just some like extremely archaic ways of thinking about about software engineering specifically, including this sort of hubris where you just have to write all the code 100% correctly, otherwise you just don't get to ship a product. And like, because that never actually works, like, well, you end up having bugs that have the ability to, you know, like there have been bugs that just really shouldn't have been a big deal that turned into like severe security bugs because the architecture didn't have the kind of defense in depth that I would have wanted it to have. And so that was a really frustrating experience to be there and to kind of know what I thought the right strategy was, at least, and just to have absolutely no way to get anyone with the power to like accept those changes, to care. So that was always frustrating. Anyway, I'm sure a lot of you who work in big companies can relate to that feeling. So I've got these two VMs. You're only going to see logs from this VM here, and it's going to be somewhat chatty because that UI option that turned on USB verbose logging also, I think, switched. Actually, that's not true. I was going to say it switched the whole VMX to a different, more debuggy build. I think that's also something that changed at some point in the past. It used to be that to get USB logging, you had to have just a debug build of the whole VMX. But I think that's now not the case because we wanted it to be easier to debug USB at some point in the past. So I think this is actually not a full debug build. Let's check. Yes, up here, option equals release means it's not a debug build. But we still have USB logging. We haven't seen any yet. So do we have anything from the USB subsystem? We've got initialization here. So these are all different virtual devices. I've never seen this before. Virtual RNG, is that a random number generator? That's new to me. CCID is a smart card. Mass storage is, like you'd expect, a USB storage device. I don't know if that's being used right now. This was like an intern project at first, and then it actually turned into something we shipped for a while, but I don't know if it's still being used. It had like kind of a weird like niche purpose that we ended up using it for. So yeah, I don't know what that's currently used for. And then virtual HID is that mouse that's like going to be active by default unless you disable it. So anyway, we have USB. We have not seen any USB packets, which would show up as USB I/O. So here you can see it finding devices. These little key value strings are how it represents devices that have not been connected yet. Anyway. So far this is nice and quiet. Let's try plugging in our camera. What is this device? Why are we not seeing it in that list, actually? So we're seeing it here as RGB IR camera. I'm looking for reasons why this device might be filtered out by default. Going back to that device list we were just looking at. Yeah, so here we have found device, Quanta RGB IR camera. We can just see what it thinks about this device. It's a video class device. This path is where it's physically plugged in. That device should be attachable. I wonder if the UI is filtering it. I don't know why the UI would be filtering it. The other thing you can try is to use Focus Auto Connect, where if the VM has focus and you plug in a device, it'll, at least the way it used to work, is it would actually very reliably attach the device, regardless of what was going on with the drivers. It had this really low level, really reliable way of always attaching the device. But I think this feature that came in, I don't know what the time frame was, you'll probably see it in a sec, where it gives you a dialog box that asks where you want to plug this new device in. That dialog box is not nearly as reliable as the old system, so I don't know if this will work, but let's try it. So I'm just physically unplugging it, and then I'm going to physically plug it back in. This really looks like the UI is filtering it, because the VMX is seeing it and logging it. But I don't get a pop-up at all in the UI. That is really frustrating, and how would we even debug this? So, I mean, there are multiple ways of approaching this. We could try attaching this without the UI's involvement, really, by adding a USB Auto Connect line to the config file. I know at some point after I stopped working on all of this, they were adding like USB camera virtualization support, where there's a virtualized USB camera device, which then attaches to your host's camera drivers, like through a video API. And so it's possible that in order to make that feature less confusing, they added a filter to filter out camera devices. But if they added the filter to the UI rather than to the VMX, then it would be difficult to debug and disable from this perspective. Let's just see if we can find anything relevant in public documentation first before we go too deep into this. Yeah, this seems... Yep, that is exactly... They added a fucking UI preference. This is not the right way to implement it. At least it's not consistent with the way the rest of the system is designed, which from my perspective would mean that it's not the right way to implement this. This is terrible. And this is a UI preference, which means I've got to shut down the UI. Suspend all of this. So no, David, it's not just like HID. My complaint here is that they implemented this wrong. This is not implemented like HID, which is done at the USB device enumeration layer. They did this by just filtering it out of the UI after the VMX hands a list of devices to the UI. And it's inconsistent with how the rest of this works, and I don't know why they would have done it that way, except that somebody got a bug request to add it to the UI, and they didn't feel like talking to anyone on the VMX team. It's completely not the right way to do this. Library preferences. Because this is not a per-user preference, it's a per-VM preference. All the rest of the USB attachment and filtering preferences are per VM. This does not belong here, in the slightest. I am tempted to binary patch this. Yeah, so there's not any existing option here. Why is it... Okay, everything here should start with pref or hint. Like, really? Who? Okay, VUSB camera, really? Yeah, of course it's in. But see, the thing that has me concerned is like what other preferences are here. The camera itself is implemented in the VMX layer. How are they passing, like, is this the only preference? Are there other things that they're now passing from here to the VMX? Like, why? Why would you do it this way? Is that the only preference? Did they just not know the right way to do this? I think they just didn't know the right way to do this. You know what this is? This is right here. This is how they would be sending this to the VMX. This is part of the RPC mechanism. So like they're just reading this in the UI and then sending something to the, I don't know why they're doing it this way. This is not at all consistent. Gosh, this is the old RPC mechanism. This is the new RPC mechanism. I don't think I'm ever going to see the old RPC mechanism go away. Gosh. It just makes me angry reading the strings on this code. Sorry. Let's see if that fixed it. There it is. Why would they filter it out in the UI? That's just... And I've seen, like, the code that does that RPC interaction is, like, the worst. I mean, unless they've rewritten it, it's the worst piece of code. So, like, I can't even imagine what would cause that to be the shortest path, to add some filtering to that awful piece of code, than to add another condition to an existing system for filtering that already existed. Like, oh gosh, it just makes me existentially ill, basically. Okay, so we can see the device now. Let's attach it. So we had a big spurt of activity and then not much. Let's see if Windows is installing drivers. Yeah, so the teams, like at least when I worked at VMware, the teams that did development for UI versus stuff that's in that VMX binary were pretty separate. And like occasionally you got people who were mostly working on one thing and would submit patches to the other thing. But by the time I was there, there was a pretty large degree of separation there. So it just, I mean, it just to me indicates that there was a breakdown in communication, and instead of either someone taking the effort to cross over and being the UI developer who writes the patch for the VMX that fixes this, or even just like writing an email to the right person and getting that feature in, like neither of those happened. Instead, they just added a really, really half-assed implementation of the feature that was solely on the UI side. And it just makes me sad. And I'm not at all surprised, because the UI culture there was always really dysfunctional, at least the parts of it that I saw, the time and space that I interacted with. Maybe it was better when it was like a 20-person company, but I interacted with it when it was like a many 100-person company, and it was already pretty hard for communication not to break down by that point. It seems happy. This might not be able to keep up with the terminal spewing like this. If it can't keep up, it's quite possible that we just won't see any frames. This is actually when it is kind of useful to take that max line option and turn it way down, like to 1 or 2. Because then you can still see the headers for the transactions, and you can see the timestamps, but you don't actually clog up the whole system with logging. It's not even the disk bandwidth that's slow. I think it's really just, it's just like the logging code is not actually very fast. That was like the understatement of the century. Yeah, no, the logging code in this code base is very, very not fast. All right, yeah, let's make that change. I don't think I'm gonna get anywhere with the full logs here. This is a case where hardware, oh, am I gonna save enough CPU just by not tailing the log? I think what we're seeing is that some individual isochronous packets are dropping, and so we're seeing the driver doing a kind of bad job at recovering from those packet losses. Yeah, let's have just packet headers, as nice as the glitch art is here. So I'm going to suspend the VM. I know I just said you should only edit the VMX files with the UI closed. Sometimes I get lazy and I'll edit them with the UI open as long as I don't interact with the UI, but just be warned that the UI can clobber your file pretty much any time. Am I gonna have to unplug this device? That certainly helped. Okay. Ken has suspend now. Yeah, I'm pretty sad that some of the code that I'm actually proud of at VMware is locked up inside of this product that is full of so much really bad code also, you know. It's like I still find it a useful product. I still prefer it to like VirtualBox or certainly to Parallels, but it is frustrating that it isn't better, and it's really frustrating that it isn't at least based on some kind of open source core. Am I gonna have to just kill the VMX here? Why can't I suspend? Seriously, why can't I suspend? It's trying to like ask the guest nicely to run pre-suspend scripts, and I don't want it to do that. I just want to suspend. No, I think this is a VMX bug. You saw it really quickly transition to suspend state and then back. I don't know what's happening here. That's definitely a bug. I'm glad it's not my bug. That is the first one. Cool. Okay, So I'm going to change this max line from something outrageously large to like 2. That'll log only like the first 32 bytes of each packet, I think. Yeah, I mean, VMware, when I was there, was never great at communication. I mean, sometimes it worked, but only because the teams were like small and had pretty good, you know, kind of alignment between the team structure and the technical structure. But when that alignment didn't exist, it was really hard to get stuff done. And there were a couple of cases where there were acquisitions where, you know, VMware acquires a company that was used to working in a particular way, and then their communication just like completely broke down because nobody knew how to manage that. Updates. Yeah, I mean, I'd love to have open source virtualization on macOS, and like VirtualBox it's like all right, but yeah, I don't know. Sometimes I do think it would be fun to contribute to its virtual hardware support and help it out. What are we doing here? Yeah, so there's some USB I/O. I think that's us getting the USB hub set up. In this case, these packets were pretty small anyway. But if they were longer packets, we wouldn't be seeing very much. Like here we go. This one's getting truncated. This is, I think, the virtual hub. Yeah, graphics acceleration is just such a huge problem in VMs. I mean, it's just really hard to do and really hard to get right, and involves maintaining a large code base. Oh gosh, why are we doing this now? Alright, I'm gonna pour some coffee. There's not very much coffee left. BTW Brand on YouTube chat says that they haven't updated their OS since install. All the features I want were there from the start. You are the proud owner of numerous security vulnerabilities in that case. Congratulations. Which is fine if you never connect your computer to other computers. That's just pretty uncommon these days. How is everyone else's Friday? It is a Friday the 13th, which I'm a fan of. I don't know if anybody else likes Friday the 13th. Welcome, user. Yeah, that's the thing, like, people who never update the software, it's kind of like never getting vaccinated or something. It's like fine, kind of, if you're gonna live in a bubble and never interact with anyone else, but in the real world where you exchange data with people nearby, it's just kind of irresponsible. All right. Oh my gosh, what is happening? I really don't care. Go away. We don't need one drive. We already got a drive. So, are you done being slow yet? You are not done being slow. Let's gosh. That is the right VM, isn't it? Yeah, you're doing a bunch of like... You know, every time I see this anti-malware service executable, I'm always misreading it as animalware. It's like, oh man, sure are running a lot of animalware programs. Okay, well, this may make things slow enough to drop frames potentially, but let's give it a try. I'm gonna do my tailing of the log file again. Let's make the windows smaller. I wrote that log message. And a bunch of the code behind it. Oh, yes. We want this one. Okay, we're getting a little packet loss, but it's enough that we're getting an image through at least. Oh, wow. My precise location. I'd rather not, but thanks. It's not like this VM has a GPS device. So, you know, this looks kind of like it has a bunch of I/O transfers queued, and if a particular transfer doesn't complete in the time frame it's expecting, it maybe just uses that data anyway. So we've got what looks like a mix of old data and uninitialized memory in the dropped packets. Yeah, this is not working as well as I'd hoped. I could try making the log even. I mean, is this better if I just stop stressing out the terminal here? This is still not amazing. Oh, you know what? This is virtual EHCI. Let's try out virtual XHCI. I think we might have better luck with that. I'm not biased at all. I wrote the virtual XHCI. Or at least I like wrote the initial version of it at least. You know, every part of this was a team effort, of course, but like I did a bunch of revamping and maintenance on the EHCI backend, but I didn't like write that one. I wrote like a lot of stuff from the ground up though, and so I've got like stronger feelings about those pieces of code. All right. I think we just want to enable XHCI. So if you plug a USB 2 device, like a high-speed device in, even if you have an XHCI controller in the guest, it's not going to use that by default. It'll, just like in a real system, it would be connecting that to an EHCI controller. However, I could go in and disable EHCI and force it to use XHCI, which is something that I would certainly do a lot during development, and might be worth doing now, honestly. I don't remember the options to do that, so let's go grepping. So this is the strings from the VMX again. Is my VM off? Yes. I think it's just ehci.present. Oh yeah, that's table driven now. And then usb.uhci, that's kind of an outlier. There's really no consistency in the naming conventions. Okay, so we have usb.present and ehci.present. USB.present is for like the entire USB subsystem, so we want to leave that set to true, but set usb.uhci.present, which is this is the host controller that's used for everything under high speed. So you would usually think of that as 1.1, but it's more about the speed than the version. And then EHCI false, and I think we can just force it to use XHCI for everything by having that be the only one available. Yeah, USB underscore XHCI, really? I forgot it was like that. Okay. Let's see if that does what I expect it'll do. I don't really know, but I think that'll give us an XHCI only VM. David's saying something about problems with XHCI on macOS. So what do you mean with macOS? You mean for like macOS VMs? Because I'm not, this has nothing to do with the host USB stack. I'm only reconfiguring the guest USB stack here. The host side will be the same with or without this change. So to be clear, I'm using the host's USB controller in USB like 2 high-speed mode, but telling the guest that it's actually a super speed device and connecting it to XHCI. Lying about the speed, but using XHCI as the controller. It might not work because of the way the isochronous frames are calculated. Like an isochronous device is like the least likely to work out of anything, but I thought it would be worth trying this out since EHCI was not working super well. I could also try tweaking some EHCI parameters, but that's probably not gonna help. Well, we're doing something with the interrupts on XHCI at least. Go device manager. Yeah, my hunch here that I'm following by using XHCI is not because that's the way it's supposed to work, it's because I think the XHCI driver is maybe more reliable in particular ways because XHCI is just an easier to virtualize host controller. Virtualizing isochronous transfers specifically on any of the other kinds of controllers, it's just a huge hack. Like, I mean, I tried to do a really good job at it. Like, it usually works, but it's just fundamentally a hack the way it has to work. It involves kind of looking into the future and trying to figure out when packets actually show up in the schedule ahead of when the real hardware would be able to notice them, usually. This looks fine. We've got XHCI and a root hub. Connect the camera. We've got a camera. Yeah, so we can see now right away that it's connected to XHCI. Did we just get one frame and then it crashed? It was a good frame though, right? I don't know what's going on here. I'm wondering if this might actually be like more of a graphics issue than a USB issue. Because the way it seems to just be differently aligned noise depending on the size here, I wouldn't expect that if it was just a USB problem. But, I mean, I don't know. Does anything happen differently if we reopen it? Oh yeah, it's better now. Alright, well this is not optimal, but let's see if we can at least try out the Windows Hello mode to see if we can get an IR video. Yeah, this VM doesn't even have a password set. Password. Yeah. So I was expecting it to actually show right here that we have a compatible camera attached. Let's just try replugging in the camera and see if that makes any difference. We could also try running this part again without the XHCI experience, because it could be that's interfering with whatever this is using to recognize the device. I would be surprised though. So I assume it's probably just looking for some aspect of the descriptor and then starting, you know, either it's a completely normal UVC camera that just has specific capabilities, or there's going to be some other way of putting it into a secure mode that they would be initiating once they identify a compatible camera. Yeah, I'm gonna turn EHCI back on. If this keeps failing, we could try a completely different approach and use a physical Windows machine and a physical USB analyzer, which seems pretty likely to work. I just wanted to try demoing this, but can't win them all. Okay, I'm gonna turn off XHCI because I don't, oops. We can leave the floppy disconnected, why not? So turning on EHCI, letting UHCI default on. Well, this is not checked into Git. That's a good question. David asks if a TPM is required for Windows Hello. I didn't think so, but I'm not actually 100% sure. That's a good question. The workstation I was planning on using this with, I think has a slot for adding on a TPM, but it doesn't have a TPM in it. Such a secure password. Especially because you can see my keyboard, right? Okay, so that should be connected. Okay, that is EHCI now. Pretty much the same performance. It makes me wonder if this is not a host controller related bug, but is maybe a host related bug. So like a problem with the macOS backend or something. Let's try that. Why am I not online? Yes, I know that. Yeah, I mean, I don't really care to debug the network since I don't think we need this VM right now. Alright, well, we could move this all over to the physical machine. We could continue trying to debug this. We could just call this whole thing a failure and I could move on to video editing. Alright, let's see if we can try this on the physical Windows machine. Let's do a little bit of switching here. Oh, right. You're back. trying to see if I can get the relevant parts of Windows to show up on this video output. Meanwhile, enjoy the Tuco. Just got an out of USB bandwidth error. It's interesting. I'm gonna try giving this thing its own USB port. Okay, so the camera is way over there. I'm gonna try to wave in front of it. We can at least see if it's working, but this looks like the IR image. I'm gonna try maybe a USB extension cord situation. Yeah, it seems like I just want the USB analyzer and the camera attached to that machine on different ports. We can try going about it that way. Alright, do we have the software for the Beagle? We don't. I guess I'll need that too. Oh, everything's showing up on the wrong screen. Oh, you're gonna make me log in? Really? Okay, I'll deal with that on the other computer. Alright, I've got the software installed. Let's just plug this in. Sorry this part's kind of boring. I wasn't really set up for this, but I figure it's worth just trying it out before I completely throw in the towel on this experiment. Alright, so my setup here is going to be, all of this is connected to the same computer, hopefully different USB buses. One USB bus will be going to the analyzer itself, the other one will pass through the monitor port on the analyzer and then into the camera. So I'm just going to plug all that into the rack itself and just kind of point the camera in this general direction if I can. That rack is a cute little space heater when I'm streaming. Okay, so I've got the data center software. It thinks there's no device connected. Beagle. Okay, so this is logging. It would actually be nice to be logging when I actually plug in that device. So let's try replugging the camera. Alright, so that should have been an unplug followed by some connection. You can see the decoder here kind of decoding some of the fields in the USB video class, which is nice. Alright, so we're at the bottom. Let's set up facial recognition. Sorry. Really? There we go. So these are frames. Just for a point of clarification, if you see the term frames here, these are not video frames, these are USB frames. But these objects here are video frames with a presentation timestamp. This SOF is the USB startup frame, so I think these are the number of USB frames. Yeah, so this is the counter since the SOF counter was reset. So, that's interesting. So all of these would be within the same millisecond. So this seems like these are not video frames, but parts of video frames. Are these just individual isochronous packets? That looks like an individual isochronous packet. This looks like uncompressed video. I'm just saying that because if it was compressed, you would not see runs of almost identical bit patterns. It looks maybe like this is a 16-bit value, or it's an image interleaved with something else that's typically constant. So yeah, this one thing I was curious about before I got distracted there was before it starts sending back normal USB video class data, what are we doing to put it into IR mode? That might just be the type of, like, the interface alt setting that it requests. Like, it might just be that there isn't that much going on here, that this is really just an IR camera and an RGB camera in the same package. But I was expecting at least something with some kind of encrypted mode, given some of the marketing bullet points they had. So I'm kind of curious if it goes into a different mode after the setup. Because this, I mean, this looks pretty plain texty, right? This looks like a 16-bit IR image. Anyway, let's try doing this. Let's maybe actually try putting an extension cord in the loop. Let's see if I can get to the same point, but with an extension cord in the setup. Alright, this is an active USB extension based on a hub, so we might see the hub here also. Let's replug this. That looked potentially right. Let's try a different extension cord. Maybe I can find a passive one that'll get us far enough. That was the replug. Oh, it's trying. Is that packet loss? Oh. That's packet loss, but, yeah. Oh, I can see the illuminators pulsing. Alright, maybe instead of the extension cord, I use longer cables on the other side of the USB analyzer. I think there's probably a collection of USB cables that work here. I've got a really good passive extension over here that Tuco's only chewed on a little bit. Let's use that one. Did I just crash the analyzer? Yeah, something went wrong. No kidding. Oh, I'll show you device connected. How's that? That was replugging the camera again. This is still so unhappy. Let's try a no extension cord and I'll just have to go over there. What did it just do? Couldn't quite tell what happened, but it seemed happy. Okay, let's set up a temporary pin. Oh, let's not do that here then. Okay, let's just see what the data looked like. Was that still looking like uncompressed infrared stuff? I mean, the sizes look the same. This still looks entirely uncompressed. Yeah, that's an interesting thing from a security point of view. Like, what prevents someone from, if they already have a database of pictures, for example, of making like a USB thumb drive looking thing that pretends to be a camera and just runs through all those pictures. Like, is hardware impersonation not really an important threat, or is this, am I missing something? Because I thought this might be more complicated, but it looks like it's just an IR camera sending off uncompressed images. We could try actually visualizing one of these images, maybe. So you can see this pattern where we have 205 and then 59 if you're just looking at the number of payloads here. It would be useful to know how big a frame is and where the frame boundaries are. Oh, this is a different endpoint. This is, oh, is this a different direction too? This is endpoint 1 out, isn't it? These are both ins. I think this smaller packet is flow control data. So like this might be like number of outstanding buffers, something like that. So we could ignore those and then probably just assume that each grouping of samples here with 205 payloads, that each of these is actually a video frame probably. So there's a little packet for each isochronous packet packet here, a little header for each isochronous packet. It looks like the header is 12 bytes. So that first 12 bytes is a per packet header, and then everything after that is pixel data. I don't have GIMP installed, do I? No, that web browser is really broken. Yeah, I don't know what's up with the rendering on Edge lately. Let's just do this on the Mac really briefly. Okay. This is the file we just saved out of the total phase software. So like this isn't just a single isochronous packet. This is maybe a frame. There are probably some per packet headers that we would need to strip, although this is not looking like it starts with a header. So actually it's just looking like it might be grayscale data the whole way through, which is interesting. I'm expecting those little 12-byte headers to be in there still. It's weird. I was having trouble selecting all files. Using the scroll wheel apparently worked, but okay, that's really weird. I was having trouble like actually getting the highlight to go above images the first time. How about none of the above? Is there really not an option for grayscale? There's got to be a better version of this tool. I feel like this is like minimum viable importer for raw data, but I can't imagine there aren't some other tools that have been created since then that are a little nicer. I've certainly done just like ad hoc binary data visualization tools before, but like it is frustrating that this doesn't let me visualize the 16-bit values specifically. So anyway, I could try using this in, I assume this is 8-bit indexed. Could use this in an 8-bit mode and just have the image be twice as wide as it really is. That's 340. Is it maybe actually 640? Yeah, that's our image. Not the most well-formatted thing, but oops. What did it do? Oh, is that just plus? Yep. Well, I think that's like the extent of what I have planned today, I guess. Like, we could try going a little deeper, but I don't think we're gonna really find any mysteries here. This seems like it's just an IR UVC camera, or an IR plus RGB UVC camera that has, you know, selectable streams or selectable. I didn't quite catch how it was selecting, whether that was due to the alt setting it was using or something else. But I suspect it's just using a standard UVC mechanism for that. It might be interesting to know how Windows Hello chooses the device. Like, what would it take to just have an arbitrary UVC device identified as an IR webcam by Windows Hello? Yeah, we could see if the VID PID match, sure. What was the VID PID? Oh yeah, we could actually pretty easily notice whether it's using a different alt setting in RGB versus infrared mode. I mean, these are just different sizes. I mean, they're probably different sizes and different modes. So, like, the size is a consequence of the size of the frame and the frame rate. So, like, the number of bytes that have to be transferred per USB frame. Anyway. So, vendor 408, device 7020. Oh yeah, 408 7020. Yeah, that would be. Yeah, that looks like the module. Digital microphone. I think that's optional. I don't think this version includes the microphone. Maybe that would be the the stuff that goes on some of the unpopulated pad. Yeah, the things that I think I was speculating might have been RGB LEDs. That's where the microphones go. Okay, so what was that, 408? So not these, but yeah, 7020 was the one we have. Yeah, so that matches this one. 10 FPS in YUV encoding. What is that useful for? I think by single endpoint here they really mean single USB device. Anyway, that's neat. Oh, someone was wondering how long my cable is. I don't know, probably like 4 meters or something from here to the... It's like not that far, it's just like pretty awkward. It's like from this desk over here. So then there's the rack. It's hardest to drive it into the corners, really. So it's this side of the rack, and the machine that I'm connecting it to is like right at the bottom of this side of the rack. Oh, come back, gimbal. Really? That wobble detector on the gimbal is full of false positives right now. I mean, obviously the robot is wobbling, but not in the way that the wobble detector really needs to detect. So anyway, I know it's wobbly right now, but you might be able to see a blue box on the floor with some bright lights. That is the USB analyzer. So that's where I was trying to run a cable to. The camera right now is on top of the rack there, which was as close as I could get it, really. So the YUV mode at 10 FPS, I realize that's much less compressed than the JPEG. It still like is not like RGB or before the debayering or whatever, which is what you'd want for like more serious computer vision cameras probably. But I just don't know why they would, like, what applications would want a little bit of extra image quality but at an unusably slow frame rate. Like maybe surveillance cameras or something, but that wouldn't really be useful for interactive chatting or for most things that a person with a mobile device would want that mobile device camera to do. Oh, Tuco's so great. We can come over here and have the Tuco cam be more about Tuco. Come on, Lynch. Alright, well thanks for joining me for this little investigation. I didn't quite go where I had planned, but you know, it's interesting at least to see what was going on there. And it does seem like those might be an alright source of just simple infrared cameras, but the thing that's weirding me out is, like, I don't know why they're claiming it's a depth camera. I don't know why they would like let's look at the box. Like, what are they actually saying this is? Masquerade detection by infrared camera with depth sensor. What do they mean by depth sensor here? Like, there's no onboard depth processing. Maybe they can do something with like they did seem to be pulsing those IR LEDs. I assume that that's mostly for power reduction, but maybe there's something where they can alternate between the two to get some difference in specular highlights, maybe. High security biometrics is on the box for the camera. The camera itself does not seem to have any security or any biometrics in it, as far as I can tell. I mean, it's still possible there's some other mode that it goes into during login, because we didn't really test the login aspects, but so far everything here just points to this being like an unintelligent UVC camera that has IR support. So, I don't know. Interesting. Joseph says the Windows Hello spec doesn't seem to claim it has depth sensing, just says that it's so photos won't work and for uniform lighting. Yeah, so like maybe this is just bad marketing copy, and maybe the depth sensor that they claim on here, it doesn't actually exist. And yeah, I've seen some bypasses where people used infrared photos printed out, but I wasn't sure what version of, like the one that I saw was against a different camera than this one. So I wasn't sure if there maybe was like one version of the spec that didn't include a depth sensor and one that did, but now it's just looking more like none of them include a depth sensor and this was misleading advertising. Oh yeah, I'm having trouble reading the name because it's really green on gray right now, but Xylin, I think, was asking about Tuco and like how do we find out about Tuco? Like I found out about Tuco because Tuco needed a home, and some like friends of friends were trying to look for a new home for Tuco because he'd been with somebody for a while. He was like 1 year old. He'd had a couple of different homes. Everybody likes him, but he was kind of too demanding for the people who had space for him at the time. And so I kind of randomly got connected with them, and I kind of needed a pet, and I had space in my life and in my house for Tuco, and Tuco needed a place to live, and so, yeah, you know, I kind of randomly ended up making that connection. I actually got an anniversary coming up. I don't know exactly when Tuco was born, but I know when I adopted him. And so he was about 1 year old when I adopted him, so I'm just assuming that I'll celebrate his birthday then. And so yeah, that's in August, I think. It's on my calendar, but I think it's early August off the top of my head. BTW's asking if it has autofocus. I think the focus is fixed. It looked like it was just a fixed focus lens, but didn't really exhaustively test that. Yeah, I'd be curious how the anti-spoofing works. It seems pretty apparent at this point that it's all software and that the hardware is pretty basic. But yeah, I would also be pretty interested to know how Windows detects which cameras are sufficient to use as login device sources. Like, what prevents someone from just plugging in a camera and, you know, like a camera emulator, basically, that has... So, for example, if the spoofing detection involves just looking for, like, little amounts of wiggle in the image to see if it's a real face versus a picture, could you have, like, a microcontroller that emulates that in software, and you just give it a static face, and then it adds whatever little bit of transformation is necessary to fool the algorithm? So yeah, could you make like a USB key that would be identified as a camera, would fake the motion, and would include a database of pictures to try? Oh, it asks you to blink. That's interesting. Yeah, well, I guess, I mean, I obviously haven't used this device yet because I was just unboxing it on this stream, so maybe I'll have some more insights after using the device a little bit, and then I'll be able to put together a video with this and potentially some more information. Aw. BTW says they've had their cap for 15 years in September. Good companions. Oh, that's great. Yeah, this, I could be missing a year. I think this will be 5 years in August for me and Tuco. 5 or 6? I think 5. Yeah, he and I have got a developed relationship at this point, but he's still pretty young. He's a really good guy. Alright, well, I think I should wrap up this stream and get on with the rest of my day, but I appreciate everyone joining me for this investigation, and we'll continue streaming new things and editing old things, and I'll be on the Twitter and the Gitter and monitoring the YouTube comments, and let me know what you think or if you have any requests. Also, huge thanks to all my supporters on Patreon. There are almost 400 people these days that chip in a little bit every month to keep this channel going, and that's the reason I can spend so much time taking things apart and editing videos. And so big thanks to everyone who keeps the channel going with a little bit of contribution every month, and I will continue to try to do my part and bring you the content that you want and the interesting investigations of the objects that surround us. I still feel like I kind of I struggle to figure out what the scope of this channel really should be, and one thing I keep coming back to is that I like helping people find the devices in their lives a bit less mysterious, to find ways of elucidating the black boxes around us. And I feel like that's always hard, but you know, especially these days, I feel like people have gotten so complacent about the services and products in their lives being black boxes, and actually breaking through that just requires so much time and complexity. So it feels like pushing a boulder up a hill for sure, but it also feels like maybe something that's worthwhile sometimes. So let me know what you think. I will certainly keep trying to do this, bring you the electronics and the cat and everything else. Alright, happy hacking, folks. I'll see you all next time.